We are beginning an exploration into the unseen fabric of the universe. To date, our understanding of the classical cosmos is vast. We have cataloged the immense gravitational forces that govern the life cycles of stars and defined the physics of black hole dynamics with high precision. We can map the evolution of galaxies across billions of years and track the trajectory of cosmic ray emissions as they move through the void. Yet, even with this mastery of the macro scale, we hit a wall. The rules that describe a spinning galaxy completely fail when we try to apply them to the subatomic particles that make up that galaxy. To understand how the universe actually functions, we have to look past the stars and focus on the microscopic landscape. Our guide for this journey is Nathaniel Faxon Cherier's My Dear Universe. Cherier organizes the universe into 3 layers: cosmic, quantum, and principle. These represent the same physical process, simply perceived from different viewpoints as we move from the macro to the micro. This perspective follows a logic of as above, so below. By adjusting our scale, we can see how the structures of the massive cosmos find harmony with those of the quantum realm. To bridge these 2 worlds, researchers utilize the unified quantum gravity framework. It is a theoretical attempt to merge the large-scale force of gravity with the high-energy mechanics of the subatomic. Successfully applying this framework suggests the universe is governed by one continuous set of rules, finally reconciling the conflict between our macro and micro observations. As we move deeper into this microscopic scale, the familiar concepts of space and time begin to lose their meaning. Quantum entanglement theory describes how individual particles interact across vast distances. When entangled, an action on one triggers an immediate, matching reaction in the other. Unlike classical physics, these particles remain synchronized regardless of the physical space between them. If 2 objects can function as a single unit while separated by light years, it suggests that the physical gaps we see in the macro world do not define the fundamental connections of the universe. If we move past the particles themselves and descend into the empty space between them, we reach the very bottom of the physical scale. This is where quantum hard-soft foam theories come into play. They describe space-time not as a smooth vacuum, but as a chaotic, bubbling landscape. Here, rigid, hard geometric structures maintain their form while being surrounded by soft energies that constantly fluctuate and dissolve. This kinetic, bubbling foam is the actual foundation upon which the entire cosmos, from planets to galaxies, is built. The quiet, empty space we see through a telescope is an illusion. Underneath that calm surface lies a violent and constant quantum motion. As we pull back to a human scale, chaotic textures of the quantum foam smooth out, eventually forming the vast nebulae of the classical cosmos. By mapping these subatomic mechanics, we are identifying the foundational logic that determines how every larger structure in the universe behaves. These combined rules create a unified symphony of laws, governing everything from the smallest subatomic particle to the most massive galactic structures. Embracing this connection between the micro and the macro allows us to see the universe in its full, majestic complexity. To continue this extraordinary exploration, return to MDU and be sure to like and subscribe. The boundary between outer space and the quantum realm was never a physical one. It was only ever a boundary in our understanding.